Can you hear me now? All right, thank you for letting me know. So homework 3 was due today, homework 4 was out today, and regarding midterm schedule, it is not fixed yet. I'll let you know when it's fixed. Regarding course logistics, are there any questions? Cool, let's move on. Before we talk about stacks today, let's talk about last lecture's 2 PPP problems. The first one was implementing these add nums function. And we're going to receive 2 linked lists. The first one represents the first number, 74, and this one represents 543. And what we can do is, first we are going to loop through all the items inside this linked list. So while we're going to travel through the LLs, 2 LLs. And what we are going to do is read one number from the first LL, and we're going to read another number from the second linked list. And after this, we're going to add these 2 numbers. And when we're adding these 2 numbers, there is one thing you need to keep in mind. That is, these 2 numbers, for example, 5 plus A, could make 1 carry. In this case, carry is 1, and the result is going to be 3. And when you read the next number, when you are adding these 2 numbers, you need to consider this carry in addition to the carry. And here we are going to create a list, empty list, and you are going to append the results to this list. And after all, we are going to return this result list. That's all you need to do. So basically, this is the logic of implementing this add nums function. And you can think about it on your own after class and try to solve it on your own. And that is the basic idea. And regarding this problem, we want to check whether our linked list is circular or not. Here we can use something called 2-point technique. What I mean by 2-point technique is like this. Let's say we have 2, 1, 4, 3, 5 as our input. And what we are going to do is having 2 points. And one is called a slow one. So this one is called slow. And this one is called fast pointer. And what we can do is we start from the front. And at the next stage, the slow pointer moves just 1 point. However, the second pointer, which is faster than the first slower pointer, moves 2 steps like this. And we move these pointers until one of them which is the end of the list. However, if there is a circle, that means at some point, these 2 pointers might point to the same item, same node. If this happens, that means there is a circle, because slow pointer and fast pointer, they cannot coincide because they have different speed. However, if they end up at the same node, that means there is a circle. So this is how we are going to tackle this problem. So this is the basic idea. And after class, try to implement this function. I will know the solution after class. So regarding these 2 problems, are there any questions? All right. Then let's talk about stacks. First of all, let's talk about the definition of stacks. What is a stack? In our daily lives, we use stacks quite a lot. Stacks work in this way. So at the bottom, we put some item, and we can only put items on top of the previous items. So new items cannot go between or at the bottom, but new items can only go to the top, as this figure shows. And when we want to retrieve some items, we can only access to the top items, but not the middle ones or the bottom one. That is basically what stack is. So formally, a stack also stores a collection of elements or items and behaves as a stack of books, where you can only access to the top element. You can only add new items to the top or retrieve an item from the top. And this principle is called last in, first out. So the last item got into the top gets retrieved first. The last one going into the stack gets out for the first time. That is what a stack is. And stack abstract data type defines the functionality of a stack. And we basically need to define the stack using constructor. And we need to be able to push some items. And we also need to be able to see what's on the top of the stack. And we want to return the items at the top of the stack and remove it from the stack. So this is what this pop method is doing. And we don't have to pass an argument to this pop method or top method, because we know that we can only access to the top element. So this will, and these 2 methods are going to handle top items. And isEmpty method returns true if there are no elements on the stack. Let's implement stacks together. By the way, stack itself is quite straightforward and very easy to understand. Thus, in this class, we are going to focus on applications of stacks. All right, let's implement stacks together. There are multiple ways to implement stacks. But before we do that, let's define 2 error functions, error classes. That is going to empty stack error and stack overflow error. This one occurs when stack is full. And this one occurs when stack is empty. When stack is empty and a user wants to try to get some item from this stack, then this empty stack error might occur. And this one occurs when users try to pop some items from the stack when there is nothing inside the stack. And stack overflow exception occurs when the stack is full. And this occurs when users try to push some items, new items, when the stack is full. First of all, we're going to implement a stack using Python list. In fact, Python list itself can be regarded as a stack. Anyway, let's have a look at how we can deal with Python list to implement a stack. First, we are going to define the constructor. And we are going to store our data in Python stack, Python list like this. And we are going to implement isEmpty method. And this is going to return whether we have some items inside our list. So if this one is 0, that means this stack is empty. And when we want to push some new items to this stack, that is quite easy. We just need to append this new item to our internal list. That's all we need to do. And when we want to check the item at the top, we need to define this top method. And if stack is empty, that means we cannot return anything, but we are going to raise empty stack error. Otherwise, we are going to return the top item that is going to be at the end of this stack. So in our view here, stack was vertical. However, in our list implementation, it is horizontal. So when we store items like this one is the bottom item, and this one is going to be the top item. So that's why we are returning the last item. And we need to be able to pop the top item. And as before, if this stack is empty, then we cannot pop anything. Otherwise, we're going to pop the pop item. And this pop method is supported by the Python list. So we can just use this method. And we can additionally define this size method, which returns the length of self data. This is our basic stack. And when we want to test this stack, you can check if isEmpty is working perfectly. And we can push some new items like this. After the push, so after the initialization, stack is empty. However, after the push, it has item 5. And we can push other items like 8 and 9. And when we print the top item, you can just call this top method. It's going to say the top item is 9. And we can pop some item from this stack. And after popping, the top item becomes 8. And when we call pop again and again, So after poppings, the stack becomes empty again. So this is basically our stack. Any questions up to this point? So as I mentioned, stack is quite easy. Maybe the easiest concept in our class. Seungjae asked this question, when we implement stack in this way, is there going to be a case where stack overflow error might occur? If that is a very good question. In this implementation, stack overflow error might not occur in this case. That is a good question. However, if you do not have Python list, and towards the end of this class, I'm going to talk about how we can implement stacks using arrays or other data structures. In those cases, stack overflow error can occur. However, in this implementation, stack overflow error does not occur. That is a good question. Any other questions? So I'm going to give you today's first PPP exercise. That is going to be implementing this min stack. By the way, you can inherit this object class. However, it doesn't really matter. If you don't put this expression here, that is injected here automatically. So don't worry about this. Anyway, this is our first PPP exercise. And what it does is it keeps track of the minimum value inside this stack. So when we first define this min stack and push -2, 0, and -3, and this method, this get min method, keeps track of the minimum item inside this stack and returns that item. And when we pop this item, -3, then the min stack pop becomes 0. And when we get min, then new get min becomes -2, because this is the minimum value between 0 and -2. So try to solve this problem, and I'm going to give you a template. So you first need to implement this constructor, and you need to implement this push method, and you also need to implement this top method, and you need to implement pop method as well. And the last thing you need to do is implementing this get min method. So basically, this one is similar to our basic stack. However, in some way, you need to modify the implementation to support this get min method. Before you tackle this problem, please send me a PPP message and try to solve this problem. Another constraint is try to make this get min method O1 operation. Don't make it O n. And here n is the number of items inside this stack. All right, everyone. Thank you for sharing your answers. Most of you are implementing this method in this way. I guess I haven't mentioned this before. Most of you implemented this min stack in this way. First, you define this stack as a list, and then you return the minimum of this value. And the problem of this min function is that it takes on. So you cannot just call this min function to implement this get min. I'll let you know how to implement this. Let's discuss this problem together. When we first push -2, what we are going to do is keep track of minimum value using another stack called min stack. So when this value is the minimum value, we are going to push this value to this min stack. And after we push 0, what we are going to do is we are going to update this normal stack as 0. However, this 0 is larger than -2. So this min stack stays the same. And when we push -3, what happens is we update our normal stack as -3. And because this -3 is smaller than this -2 in this min stack, we are going to push -3 here. So let's say when we push 5, then we are going to push this 5 here. And because 5 is larger than -3, you are not doing anything for this min stack. And when we want to retrieve the minimum value from this stack, we're just going to return this value. And let's see how we can do that together. So that is basically what we are going to do to implement this min stack. First, we're going to implement min stack like this. And when we push a new item to this min stack, what we are going to do is just update our normal stack in this way. However, when we are updating our min stack, we need to check some conditions. We are going to check whether our min stack contains an item or not. That is by running this not self min stack. This means this one contains no objects. Or self min stack, we are going to check the last item in this min stack, and this one is larger than or equal to the current item. Then we're going to add this item to min stack as well. So you need to be careful about this condition. The top operation is basically the same as normal stack. So we are just returning the last item at the top. And when we are popping a new item, what we are going to do is just pop the item from our normal stack. However, we need to be careful how we are going to update our min stack. That is, if this temporary value equals to the top item in the min stack, that means we need to remove this item from min stack as well. So we are going to pop this item from min stack. Otherwise, you are not going to touch min stack. And then we return temp. And when we want to get the minimum value, what we are going to do is, I told you that this takes O(n). We're going to return the last item in the min stack. And this takes O(1). So this is how we implement our min stack. Are there any questions regarding this min stack problem? So this one was pretty tricky. This one takes O(n), so you cannot use this default function to implement this get min. Any questions about this problem? Okay, let's move on. So up to this point, we saw how we can implement stacks using Python lists. From now on, we're going to talk about how we can implement stacks using arrays. This course is about data structures, and sometimes you might need to use other languages. In those cases, you cannot use lists as in Python because other languages do not provide Python lists. However, more general idea is using arrays to implement lists, to implement stacks. So I'll show you how we can implement stack using arrays. The basic idea is like this. Because we are using arrays, we first need to assign a specific memory space for this list. And we're going to initialize the array in this way. And we're going to introduce a new variable called top of stack, TOS. And this one indicates the top position. In the initialization stage, TOS is out of this stack because there is no item at all. However, after we enter push or new item like this, and TOS becomes here. So when we want to get the top item, we're going to return the item that this TOS is indicating. When we push new item like this, and TOS becomes this one, this position. And when we remove this item, then we just simply need to change the position like this. So that is basically how we use arrays to implement stack. Okay, let's implement the constructor first. In this case, we need to pass capacity. In our previous implementation, we didn't have to pass the capacity because we didn't have to assign a specific amount of memory space for stack. However, in this case, we need to specify how much memory space we're going to use for this stack. And the self data is going to be none times capacity. And when you multiply some numbers to this list, then it repeats this non-element capacity times. So let's pass default value like 10. And we are going to define TOS as -1. And I told you that this is top of stack. And what we are going to do is implementing empty method. This one checks whether self TOS equals -1 or not. And when we want to push new item, what we need to do is, first we need to check whether our stack is full or not. So if TOS plus 1 equals the length of our array, that means our stack is full. Then we are going to raise stack overflow. So this error occurs here. Otherwise, what we are going to do is increase TOS. And at this position, we're going to add new item. So this is how we implement this push. And some of you might have heard stack overflow. When you use Windows, sometimes you see blue screens. And there, this stack overflow error is specified because our stack is full. And I'm going to explain this stack overflow in more detail later. However, basically blue screens of like Windows operating systems is this one, when stack is full. And operation systems keeps track of its internal stack, and when it gets overflown, then this error occurs. And there is a very famous website called Stack Overflow. This one is for developers. If you have some questions regarding developing your own applications, you can ask questions here and you can answer other people's questions. So this is a very famous developer community. Anyway, Stack Overflow is that famous. And another thing we need to implement is the top method. And if self is empty, then we're going to raise empty stack error. Otherwise, we're going to return the item at the position of top of stack. And when we implement this pop method, it's pretty simple. We need to check Hein asked, if this Stack Overflow error occurs, then do these two lines execute it? No. The program stops here, right at this position. So below this line will not be executed. So these two lines will not be executed when this occurs. And when we try to implement this pop method, we first need to check whether our stack is empty or not. We are going to retrieve the item at this top of stack position, and we are going to decrease TOS by 1, and then we are going to return item. So this is how we can implement stack using arrays. This implementation is more general than the previous implementation, because as I told you, in other languages we cannot use Python lists. However, we need to basically use arrays. Let's test our stack implementation together. Let me run this. This basically does the same job as before. And so this is the second implementation. And the third implementation we can take is using linked lists. So linked lists resolved the issues of arrays, because arrays have fixed memory space, and that is somewhat inflexible, not flexible. So that's why we implemented linked list. And that same issue occurs here for this array-based implementation of stacks. So we can use linked lists to implement stacks. And this is going to be our second PPP exercise. I'm going to give you the definition of node. So we are going to use singly linked list to implement our stack. So this was our node class for singly linked list. So your job is to implement stack using this node and using linked list. The first thing is you need to define constructor. Second thing is empty method. And the third thing is you need to implement this push method. And the fourth thing is top method. And the last thing is implementing this pop method. Try to implement stack using linked lists. And for that, you need to implement these 5 methods. Before you tackle this problem, please send me PPP message and try to implement this stack using linked lists. All right, thank you for sharing your answers. Dongsu suggested this, giving default value to this next node. That is very good. Let's implement this together. We are going to keep track of the top of stack. And to check whether this stack is empty or not, we just need to check whether our TOS is none or not. And to push new item, we need to check whether we just need to update our TOS by creating a new node using this item, creating this new item. And previous TOS becomes the next item, the bottom item, and the new node will become new top of stack. And when we want to implement top method, we first need to check whether this stack is empty or not. And we're going to raise empty stack error. Otherwise, we are going to return the item at the top position. And when we want to pop some item from this stack, we need to check whether this stack is empty or not. Otherwise, what we are going to do is get this item from the top position. And we are going to update our TOS to the next item of the current TOS. And then we're going to return this item. So this one is quite similar to the top method of array-based stack. So this is how you implement stack using linked lists. Are there any questions regarding this implementation? Cool, let's move on. So up to this point, we discussed how we can implement stacks. And from now on, I'm going to discuss some application. There is one question. If you implement this pop method, so what do you mean by data? 승재. Dongsu asked this question. What is the difference between implementing this empty stack error and what is the difference between where was it? Raise exception stack is empty. Basically, these two things do the same thing. However, we want to explicitly define this error to specify this specific situation. So when this occurs a lot, then exception stack is empty might be not general. I mean, some people might use different error messages, and we want to make it consistent through all use cases. So in those cases, if this error occurs a lot, and this is quite general case, then we are going to implement this exception as a class, and the error messages become consistent. So that's why we are implementing this empty stack error class. So basically, these two things do the same job. However, this is the difference of styles. Does this answer your question? Okay, so I told you that there is something called stack overflow error. And in fact, our computers have stacks. And stack frames store local variables of a function. And it gets created every time a function is called and gets destroyed when the function returns. The start times and return times of functions form a nicely nested structure, just like the balanced parentheses. And this is actually stack. And the Python interpreter keeps all stack frames on a stack. And Python can store 1,000 stack frames. So if you call more than 1,000 functions using recursions or other things, then stack overflow error might occur. So that's why we need to sometimes use iteration rather than recursion. And we saw this example before. When we run this one first goes to this try block and prints beginning of try block, and then executes this operation and then goes into fn. And fn was executed, and the starting of fn is executed here. And then it goes to G, and G starts here, and it prints out starting of G here, and then calculates or operates its job and prints out the result of this operation here. And when the last function that was executed is G, then it should be the first one that should be ended. So try block starts, F starts, G starts, then G should be the first one that needs to be returning. And the next one is the second last function, G, that is going to end, terminate. And because the try block was executed for the first time, it's going to terminate for the last time. So as you can see here, this one looks like a parenthesis or stack. First in, last out, or last in, first out. So that is basically what stack is doing. So you are going to learn this concept in more detail in computer architecture class. But anyway, they use stacks to handle or manage the function calls. So that is another application of stacks. And I'm going to show you another application of stacks. That is because the first one that goes into the stack comes out the last time, we can do something like checking the balance of parentheses. So for example, and you see this, this one is correctly balanced because the opening one is closed with the closing one, and these curly braces is ended here, and between them, everything is balanced. So this one is balanced with this one, and this one corresponds to this one. So we all know how we balance our parentheses. And when you see this, this opening one is closed by this one. So it is not balanced. And how do we implement a function to check whether our parentheses are balanced or not? We can do that simply using a stack. So let's see how we can do this. So the strategy is like this. We are going to first make an empty stack. And our second job is for each string, and this string can be parentheses. What we are going to do is, if the symbol if this string is an opening one, then push it to the stack. That's what we're going to do. And if this one is closing one, we are going to check three cases. The first case is if the stack is empty, that means it is not balanced. So we are going to return false, meaning not balanced. And the second case is the top does not match the closing one. This case is also false case. The stack is not balanced. And the third case is top matches the closing one. Then we just move on. So we repeat this process again and again. And if the stack becomes empty and we processed all the strings, we are going to return true, meaning the stack is balanced. If the stack is empty. Otherwise, we are going to return false because there is something remaining in the stack, meaning that the stack is not balanced. So I'm going to show you how we can implement this. So what we are going to do is, if these symbols are balanced or not. So this one should return true because this one is balanced. And this one should return false because this one is not balanced. And how can we implement this? We are going to just implement this strategy. So basically, we are going to define a stack like this. And for each character in this string, I told you that we need to check this one. So for each string, we need to check if this string is an opening one. So opening ones are these parentheses, curly braces, and bracket. If these ones are in this opening characters, then we are going to push this character into our stack. So that is our first case, this case. Otherwise, if string is closing one, then we need to check these three cases. So if stack is empty, and we need to check whether this closing one matches the top item or not. And to do this, we're going to define another function that checks match of this opening and closing one. This one is quite simple. We can implement this one using a dictionary. We're going to check whether the closing one matches the opening one in this way. And we're going to return open in this dictionary. And the opening one corresponds to the closing one. So this one is our matching function. We are going to just check whether the top of stack matches the current closing one. So if the stack is empty or the stack top does not match the closing one, then we are going to just return false. Otherwise, we are going to just pop the top item from the stack. So we are just repeating this process again and again. Okay. And after all, we are going to return stack is empty or not. If stack is empty, then all the parentheses are balanced. Otherwise, it is not balanced. So this is how we implement this strategy. Any questions up to this point? So this is one application of using stacks to check the balancedness of symbols. If there is no question, let's move on. And another application of stacks is implementing calculators. This is going to be our last topic, today's last topic. To implement calculators, we need to use some special notation. When we evaluate this mathematical expression, we humans know that we need to execute this two operations first, and then this one. However, for computers, going forward and backward is quite tricky. So rather than doing this, we are going to change this one as 3, 1 plus 4 times. So rather than expressing these mathematical expressions in this way, we are going to, so basically what we are doing is put operands first, then operator. This is what this expression is doing. And this expression is called reverse Polish notation for mathematical expressions. And when we turn this expression into this reverse Polish notation, the computer can easily evaluate the value of this expression. So we are going to put operands first and then operator. So what we can do is retrieve these two operands, 3 and 1. And then the next one is going to be the operator. Then we are going to add these two numbers. Then this one becomes 4 times in the next line. And then we are going to retrieve these two numbers and then operator like this. And the value becomes 16 like this. So we can implement calculators by reversing this expression into reversed Polish notation and then evaluate this Polish notation. So I would like to end up this class giving you the last PPP exercise. The last PPP exercise is, given this reversed Polish notation, your job is to evaluating this expression. So this is going to be today's last PPP exercise. By the way, we have only 5 minutes left, and I guess 5 minutes is not enough for you to solve this problem. So let's discuss problem next class, and let's call it a day. Thank you for your participation, and if you have any questions, you can stay here.